Our first stop in the journey through the heart is the superior vena cava, which is located just behind the right atrium. That is located right here if you look. You can see that it is short in length and wide in diameter, which allows for a steady flow of deoxygenated blood to re-enter into the heart through here. Another pathway in which deoxygenated blood may enter the heart, aside from just the superior vena cava, we also have our inferior vena cava located here.
Our next stop is the right atria, a pouch-like extension separate from the other four parts of the heart. This pumps deoxygenated blood into the right ventricle.
The tricuspid valve is what separates the right atrium from the right ventricle. This valve prevents blood from re-entering the right atrium. From the right ventricle, it will be pumped into the pulmonary artery onto the lungs.
To recap, we start in the superior vena cava, into the right atrium, through the tricuspid valve, into the right ventricle, and through the pulmonary valve, into the pulmonary artery, and into the lungs.
In addition to this, we also have the pulmonary valve, which we skipped over a little bit before, but this is the valve that is acting on the pulmonary artery. And this valve works just the same as we explained before with the aortic valve, that it will fill up with the fluid and prevent it from re-entering into the right ventricle. From the lungs, the now oxygenated blood will re-enter into the heart by way of the pulmonary vein, seen right here. From this vein, it will go into the left atria, which is this pouch. As we talked about in the right atria, it is very similar in structure. From this atria, it will go into the left ventricle by way of the bicuspid valve, which is slightly different from the right side, which had the tricuspid valve, seen here. So this bicuspid valve will prevent blood from re-entering into the left atria once it has entered the left ventricle. The left ventricle is much thicker in muscle, as you can see here, than the right ventricle is, and this is due mainly to the fact that the right ventricle only has to pump blood to the lungs, as opposed to the fact that on the left side it has to pump blood to the entire body. The last step that the oxygen-rich blood must take is to the aortic valve. This happens when it goes from the left ventricle through this valve here. The aortic valve are these bubble-looking things that fill up with fluid once the blood travels through. And how it functions is that once the blood is in, it will begin to fill up, as I stated before, and it will block off the actual aorta, preventing blood from re-entering into the left ventricle. Once inside the aorta, you will see that it takes one of two paths. The first path is here, through this valve, which will travel up to where the head is. Then the second path goes to the rest of the body, and that is this long branch of the aorta, which you can see a bunch of tiny branches actually, which is pretty cool in the holes that you can see here. And this travels to the tail end of the body and carries blood everywhere else. Lastly, we have the coronary artery, which some of which may be seen here. And what this artery's function is that it will carry oxygenated blood through the heart itself, which needs this energy in order to function. And although the parts that we have already discussed are the main players in the blood's journey through the heart, there are several other important factors that play into this. For example, we have the intraventricular septum, and this very, very thick wall of muscle separates the two chambers of the heart. And this is probably one of the most essential roles, because if the blood were to mix the deoxygenated and the oxygenated blood, the person would most likely die within seconds. Thank you for accompanying us on this wonderful journey through the heart. Bye!